Good afternoon, everyone. My name is Jason Bechtold. I'm the team lead for the Decision Aid Tool Project. With me, we have Nicole Johnson over there, our Scrum Master, and then our three developers, Leah McIntyre, Max Shabbat, and Cameron Moran. We developed the Decision Aid tool for the Naval Undersea Warfare Center. And with us from Newark, we have Meg Duckett, Samuel Bland, David Gimble, Kester Nakoro, and Abigail O'Brien. So at the beginning of the semester, our clients brought us the issue of pairing missiles to missions. So what currently happens is that what's called a fire control operator takes in an inventory of missiles from a submarine and a list of missions from higher command. And they determine which missile works best for each mission. This requires going through a lot of rules and constraints, which means if you have, say, 40 missiles and 40 missions, this could take a long time to complete. Say, for example, the very first missile you pair is the best for the last mission you look at. Now you have to go back and redo some of the pairings, which then causes even more time to be taken out. Our program aims to make this decision as quickly as possible while using up as little time as possible. So, as mentioned, this problem has many rules and constraints, but we have two types of constraints. The first one is called a hard constraint. A hard constraint is a constraint that cannot be broken. So an example of that would be if you have two missiles firing off near each other at the same time. This could be bad because of the fact that these missiles could interfere with each other, causing them to go off target. And when they go off target, they'll fail the mission. Or they could collide, which lead to catastrophic results to the submarine. We cannot allow this to happen, so this rule cannot be broken. The second type of constraint is a soft constraint, which can be broken, but we really should not break it, and it must be maximized. I'll give an example of that momentarily. So these constraints are prioritized. So therefore, to prioritize them, we give them weights. The constraints with the higher weights are higher prioritized, and the ones with the lower weights are lower prioritized. And if you add up all of the weights, you'll get the score for the solution. And as with most things that aren't golf, the higher the score, the better the solution. So as promised, we have an example of a soft constraint. So in the top left of the slide, we can see a mission missile pairing where the mission requires any sort of navigation A. So navigation A is an abstraction of what would actually be a mission requirement. So for this mission, we gave a missile with a navigation A of new. This missile can fly the mission, but it's not the best missile we could have chosen, so it's only a capable missile. In the bottom left of the slide, we have the same mission that requires any navigation A, but we gave a missile the navigation A of hold. This is the missile that closest meets the mission's requirements, making it a least capable missile. To give another example, in the top right of the slide, we have a mission that requires navigation A of none, it's not required. We gave it a missile with a navigation A of hold. This missile can fly the mission, we can do better. So in the bottom right of the slide, we can see doing better, where it's the same mission with no navigation A required, and we gave it a missile with a non-operational navigation A. That is the least capable missile. So to help us solve this problem, we use a library called OptiPlanner. OptiPlanner is a constraint satisfaction engine, meaning that it can solve the problem that we're trying to solve given an input set and a definition of the problem. We chose OptiPlanner because it has extensive documentation, meaning that we can learn it quickly and use it quickly. And it also has what's called a benchmarking system, meaning we can run our problem against multiple algorithms and choose the one that solves it the fastest. So it wasn't fast enough before, now it's even faster. So how we calculate the score that I mentioned with OptiPlanner is that OptiPlanner will change one of the mission missile assignments causing the solution to change, which then triggers our code to recalculate the score. We then give the score back to OptiPlanner, and this process continues until the amount of time we gave the program to solve times out. Other tools that were involved in the creation of this program would be GitHub for source control, Google Drive for documentation, IntelliJ IDEA for an IDE, Maven for project building, as mentioned, OptiPlanner for our solver, Java for our programming language, Java FX for our GUI, Slack for communication, and Trello for agile planning. At this point, I'd like to pass this off to Mac for the demo. Thank you.
Thank you, Jason. So this is our user interface. At the very top, you'll notice there are sections for missile and mission input. And beneath each of these sections are tables to show all of the missiles and missions that we've added so far. So what we're going to do is we're going to create a simple example to show how we'll choose one mission over another, or one missile over another for a mission. And we're going to walk through each of the fields as we do that. So to start, we're going to add a missile. The very first field here is the tube and the cell location. This refers to the physical location on the submarine where this missile is located. The payload tubes are numbered 5 through 10, and each cell within the payload tube that each contains a missile is lettered A through G. So in our case, for our example, we're just going to set this to 5A. You'll notice that the cell location does not contain a D option, and that is because payload tubes 5 and 6 only have 6 cells instead of 7. There is no D cell, so that is not able to be selected. The next field that we have is the Navigation A capability of the missile. As Jason had alluded to earlier, there are 2 different versions of Navigation A, either old or new. And it's also possible that it's not operational. So for our example, we're going to select the new design. Navigation B is another form of navigation capability that missiles have, but this one only has one version. So it's either going to be not operational or it's going to be operational. For our example, we're going to select operational. Communication is another capability that missiles have, and like Navigation A, there are 2 different versions of it, an old version and a new version. Or, again, it could be not operational. For our example, we're going to select the new design. The next field is the capability ranking. This is a number of 1 through 10 that represents how good overall a missile is and how useful it can be to accomplish various missions. As you'll notice in the drop-down, only 9 and 10 are options. And this is because this field is partially dependent on Navigation A and communication. For example, there are no missiles made that have an old navigation, an old communication, and a capability of 9. So our drop-down only includes models that actually exist. For our case, we're going to select a capability of 10 for our example. The next field is the age of the missile. This refers to the power on time that the missile is, like how long the missile has been on the submarine, basically on standby. For our example, we're just going to select 1. It's not going to play a part in our example. So we're going to add that missile, and as you'll see, it'll fill in the table with all of the information that we just entered. In addition, you'll notice in the bottom right that the payload tube cell that this missile is located in is filled in, so that you know that there is a missile actually in that cell. So now what we're going to do is we're going to add a mission that can fly, this missile will be able to fly. So the first field for the mission is the MSN. This is the mission sequence number. This is an integer number that is a unique identifier for this particular mission. It cannot be the same for different missions. So in our case, for our example, we're only going to have the one mission, so we're going to set the MSN to 1. Next is the time of launch, TOL. This is the time for the mission that a paired missile will need to be launched from the submarine before it starts heading to its destination. Again, because we're only going to have the one mission in our example, we're just going to set the time of launch to 1. The next field is the target number. The target number is a number that represents the destination of the missile, where it's going to be headed toward. So again, for our example, we're just going to set this to 1 because we only have one mission in our example. Up next, we have the Navigation A requirement for the mission. Now, Navigation A capability for missiles is backwards compatible. So if we require it for missions, we can specify that we require any version, either the old or the new, or we can specify that we require the new version. Or as Jason alluded to earlier, we can also not require it at all. For our example, we're going to set it to require the new version. Up next is Navigation B, which as I had mentioned earlier, it either is working or it's not, and for missions it's either going to be required or it's not. In our case, we're going to require it. For communication, unlike Navigation A, this component is not backwards compatible. So if you are required, you have to specify which version you want. Now for our example, we're going to say that it is not required, and I will show why in a minute. And as you can see, we now have 5A, which is the missile that we previously added, show up in our candidate missile list. This means that this missile is capable to fly this mission. If we were to uncheck it in this box, this missile would not be eligible to be selected. Although, for our example, we do want it to be eligible, so we're going to leave it checked. The next 2 fields are that for ready, spare, and primary missiles, which we're not going to use in this example, and we'll show it in a later one. What would happen if we had more missions in here is we would select the ready spare to say, yes, this is a ready spare mission. A ready spare mission means that it is a backup for another mission, which is known as the primary. So if we check the ready spare box, the primary drop-down will be filled with all missions that we previously added. We don't have any missions at the moment, so we're not going to show this, but That's how you would set a mission as a ready spare. So now we're going to add this mission, and you'll see that it shows up in this table. So now what we're going to do is we're going to add another missile. And this missile is going to have all of the same capabilities that the first missile we added had, with the exception of communication. The new missile is going to have a not operational communication, which is good, because the mission that we added doesn't require it. So when we actually solve on this simple example, you'll see that it'll pair the mission to the missile that does not have a functioning communication component. So now that that's added, we're going to hit solve. And you'll notice that it's going to take a bit of time to solve, not too bad, and then we get our solution in the table there. If we were to click on that solution in that table, it would highlight the associated mission and missile for that pair. And as you can see, the missile that was paired is the one that does not have the functioning communication. But as I mentioned, this is a pretty simple example. So what we're going to do is we're going to load a bigger example from a file. This example has 35 missiles and 15 missions, which means it'll be much more difficult to get the proper pairings. And as you can see, as we loaded the file, all of the tables are populated. Now before we solve this bigger solution, I'm going to explain the operator input section of our interface. The very first field is the number of open hatches. As I mentioned before, we have 6 payload tubes. Each of those payload tubes has a hatch covering it. Now, it is standard on Navy submarines currently to only be allowed to have 2 of these open at a time. And obviously, you cannot launch a missile if the hatch is closed. So that's important when deciding when to pair different missions to different missiles. So for our example, we are going to leave this at 2. The next field is the algorithm timeout. This refers to how long our system will try and keep finding better solutions. It'll keep solving until this time is expired. In our case, we're going to leave that at 10 seconds because that is enough time for this input set. The next field is the unimproved time. And what that means, if we have it set to 3, is our algorithm will try and solve for up to 10 seconds. But if for 3 seconds in a row the solution does not get better, it'll terminate right there. And the reason for this is it's possible for a solution to take only 3 or 4 seconds and then stop improving. And we don't want to wait the whole 10 if we don't have to. So in our case, we're going to leave that at 3. The next checkbox is to priority, which is something that I'm going to explain a little bit later, but that is one of our constraints that we can enable and disable for any given input set. So now what we're going to do is we're going to generate output for this solution. And as you can see, it's going to take some time to solve because we set it to 10 seconds. And the score will keep increasing as more time is spent solving. So now that that's done, you'll realize that we have around 3,000 points for the solution. Now, these points will be explained later as to how they are calculated, but you'll notice that there is a pattern in the location of these missiles. You notice that the first one is located in tube 10, and then the second is located in tube 9, and then tube 10 again, and tube 9 again. This is because of tube priority. So if we were to scroll down to our payload tubes, you would see drop-downs that specify the priority of the different tubes. Now, there's a number, 1 through 6, which is called the primary priority, and there's a letter, A through F, that represents the secondary priority. As you can see, tube 10 has a primary priority of 1 and a secondary priority of A, and tube 9 has a primary priority of 1 and a secondary priority of B. This means that tubes 9 and 10 will be selected over all the other tubes because they have higher priority, priority 1. However, it's going to alternate between these tubes because they have the different secondary priorities, and it's going to start with tube 10 because it's A instead of B. And as you'll notice in our solution, that is the case. Now, that's the only one of our constraints that you can really see just by looking at this output table, so the rest of our score can be seen in what we call the explain solution window, which breaks down every point that our solution is given. At the very top of this window, you'll see that it shows the score that we have. In our case, we have 0 hard score, meaning that we don't break any hard constraints, which means this is a valid solution and we can use it. And we also have a soft score of around 3,000 points, as I had specified earlier, is also shown right at the top of this dialog. The next thing is what we call hatch flops, and that's shown right at the top of this dialog because it is very, very important. As I mentioned earlier, we can only have 2 hatches open at a given time, and in order to choose a missile from a different hatch, we would have to close one hatch and open another. This is a manual process from someone on the submarine, and it takes time and effort to do that, so we want to limit the amount of times that we are opening and closing hatches if we don't need to. Beneath this is the breakdown of all the points that we are awarded. The first section is that of 2 priority, as I had mentioned earlier. For each missile that follows a 2 priority pattern, we are awarded points for it. Immediately following this, we are awarded points based on the number of times we flop hatches, and based on a ratio of how many times we're able to flop. So in this case, we flopped 2 out of a possible 13 times, which is pretty good, and that's actually an ideal situation. After this, we have points awarded for any time that we meet the least capability requirement for navigation A, navigation B, and communication respectively. Beneath this, we are awarded even more points for basically spreading our missiles out between multiple payload tubes, in which case we are awarded points based on the number of tubes already or the number of missiles already paired from that given tube. And the reason we want to spread them out between multiple tubes is because, say, for example, tube 10 the hatch is stuck, it's not able to open. Well, if all of our missions are in there, we lose a good chunk of our missions, where it's less detrimental if they're spread out between multiple tubes. We then have another constraint for ready spares being located in different tubes than their respective primary for that same reason. If we have a ready spare and its primary in the same tube, and that tube can't open, well, what's the point of the backup? We can't use it. We have another constraint for the overall capability ranking of the missile. As I had said, this was the number 1 through 10. And basically what this would do is award more points for 1 and less points for 10. Because we want to use up the missiles that are not going to be as applicable to many missions. We want to use those up as quick as we can. We then have additional constraint for making sure that missiles with the same target number are located in different tubes. Again, for the same reason as before, if one of the tubes breaks, we still want to be able to hit our target with at least some of the missiles. And lastly, we have a constraint for age. Basically, this means, because it's our lowest constraint, that if there's no other reason to pick one missile over the other, we're going to select the older one. And it's important to note that all of these weights that we have are editable. If we open up our settings menu, you'll see a few settings. The majority of them are the actual values of our weights. And these can all be adjusted. So for example, if 2 priority is our highest constraint here, but we could set it so ready spares and primaries being in different tubes could have the higher weight, and then that would change our solution. And that about concludes our demonstration as far as what our program actually does.
Thank you, Mac, for that wonderful demonstration, and thank you all for coming out to support all the teams here today. At this point, we'd like to open the floor for any questions.